Number 20 asks you to find the secant of 7 pi over 6. So a couple of reminders here. First of all, remember that secant is the reciprocal of the cosine. So if you're using the old right triangle definitions, instead of adjacent over hypotenuse, you'll be taking the hypotenuse over the adjacent, okay? Or you can use the coordinate definitions, doesn't matter. If you're using that definition, remember cosine is normally the x-coordinate over the radius, so the secant would be equal to the radius over the x-coordinate, okay? Both of these will work, okay? Doesn't matter which one you decide to use. All right, first of all, I want to draw my angle. For most of you, you're probably not going to think in radians real well yet, so for most of you, you may need to convert this over to degrees. You're taking 7/6 of 180, okay? 1/6 of 180 is 30, 7/30s would be 210 degrees, okay? So I'm going to graph a 210 degree angle here. So you're going to be rotating all the way around through 180, and then you're going to go 30 degrees more, and your angle is going to be down here kind of like this. Remember, you always make your triangle by dropping a perpendicular back to the x-axis, always to the x-axis, okay? Your reference angle, which is the angle in the triangle that you're going to be using to find all your measurements, is going to be the one that's formed with the x-axis and the terminal side of the angle. So that's right here, okay? In this case, that's a 30-degree angle, or I guess if you want to call it a pi over 6 radian angle, you could call it that as well. Okay, you can literally make any 30, 60, 90 triangle you want. It doesn't matter, although depending on what you pick, you may have to do more or less simplification. Okay, by the way, I didn't draw this to scale real well. You might want to, draw it maybe a little bit more like that. I would probably make this side radical 3. Keep in mind, these values can be positive or negative. You are going back radical 3. So that x-coordinate's negative radical 3, okay? You're going down 1, okay? Read that as a negative 1. Your hypotenuse always is going to be positive, okay, if you put those numbers in the Pythagorean theorem. So hypotenuse is positive, but your x's and y's could be positive or negative, okay? So for the secant, just pop in the hypotenuse and the adjacent side, and hypotenuse is 2. When the adjacent side is negative radical 3, okay? It is best if you try to rationalize the denominator. So negative 2 over radical 3, multiply the top and bottom by radical 3, should get negative 2 radical 3 all over 3, okay? A little bit better form of the final answer there. Okay, and by the way, if you wanted to use the coordinate definition, secant of an angle is equal to the radius over the x-coordinate. Okay, that'll give you the exact same thing. The radius is 2, if I'm using this definition. The radius is 2, and the x-coordinate, so you're going back negative radical 3, you're going down negative 1. That means the point that the terminal side passes through is negative radical 3, negative 1. Okay, so it says take the radius of 2, divide by the x-coordinate of negative radical 3, and when you simplify, or when you rationalize the denominator, you'll get the same thing. So you can use the coordinate definition, or you can use the triangle definition. Either one will get you to the same place.